So we are learning about the factor tree today. So what we do is say a factor tree may be used to help find the prime factors of a number. Below is a possible factor tree for the number 36. So here you see the number 36 is there, and then we divide it into what its factor can be. So 9 times 4 is of course 36, so these two numbers, and then we divide them again, which is 3 and 3, and of course 4 is 2 and 2. Then we circle those numbers because they're the prime numbers, and then that is how you figure out that first bit. And here from the factor trees it is possible to write, and then 36 equals 2 there, times 2 times 3 times 3, and then that equals as well in the index form 2 to the power of 2 and 3 to the power of 2. When a number is written in this way, it is said to be written as the product of prime factors.
So for this one we're doing the prime, like the factor tree for 24. So you can split it from 24 to 2 times 12, and then you circle 2 because it's prime. However 12 is not, so then you divide that by 2 again, and that's prime, but 6 is not, so you circle 2. You can divide 6 by 3 and 2, and because they're both prime you circle them, and that's also written as 2 times 2 times 2 times 3 on an index form, 2 to the power of 3 times 3.
So now we're doing 136 this time. So what we can do is 136 divided by 2. So we circle the 2, and then of course the answer is 68, but we of course circle 2, and then we divide this, which is 2 and 34. So we circle 2 again because it's the prime number, and then we divide 34 again, which is 2 and 17, and then we circle the 2 and the 17 because they're both prime numbers, and then we can write it, which is 2 times 2 times 2 times 17, also written as in the index form 2 to the power of 3 times 17.
And then we're going to do it on 216. You could divide 216 by 2, and you get left 108. 2 is a prime number, so you circle it. You can divide 108 by 2 again, which you get 54, and 2 is obviously a prime number, so you circle it. 54 divided by 2 is then 27, but you can still divide 27 by 9 and 3, and because they're both
prime numbers, you circle both of them because they can't divide by any more.
Oh
yeah, 9 can be divided more, so 3 and 3.
So you'd write 3 and 3, and then you'd circle 3,
and there.
So then you'd be left with 2 times, should I write it?
Yeah, right.
2 times 2 times 2 times 3 times 3 times 3 times 3.
And then, yeah.
And then obviously 2 to the power of 3 times 3 to the power of...
Exactly, so we could as well write it like 2 to the power of 3 times 3 to the power of 3, like that. Now we are going to 405. So you can divide 405 by, of course, 5 because it's there, and that answer is 81. And then you can divide 81 by, of course, 9 because that's the square number of it, and then you circle 9, and yeah, and then that could be 3 and 3 there. So then you can also circle them because now they're prime numbers, but this one isn't a prime number, so don't look at that. And then of course here as well you could do that, which is 3 and 3. So then you can write it again, 5 times 3 times 3 times 3 times 3. We can also write it as 5 and 3 to the power of 4.
Do you want just to show how you've done the rest of the homework?
Yeah, okay.
Quick.
So just here.
Yeah.
The number is expressed as the product of its prime. Of course, 2 to the power of 3 times 3 times 5 to the power of 2, which is 8 times 3, because that equals... No, wouldn't it be 6 times?
No, but yeah, because 2 times 2
Oh
is
yeah,
4.
yeah. 8 times 3 times 25 is 60, of course. 600 even. And then the prime factor of a number are 2, 5 and 11, which are the 3 smallest numbers with these prime factors. 1, 110 and 220. And then which is the smallest number that has 4 different prime factors. Here is 1, 21, 3 and 7.